Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to Learning by Solving Problem, Session 4 on NMR, Structure Elucidation of Organic Molecules. Deduce the structure of C9H7NO3 given proton NMR recorded at 250 in deuterated chloroform. Since we have the molecular formula, we can calculate the unsaturation number. The unsaturation number U equal number of tetravalent element plus 1 minus half monovalent element minus the number of trivalent element. So we have 9 carbon, 9 plus 1 half. Monovalent we have 7 hydrogen. Trivalent we have 1 nitrogen, and that makes the unsaturation of 7. Well, we have here doublet, we have here doublet, 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 and here doublet of doublets. To summarize or tabulate the data: chemical shift, multiplicity, J constant, integration, assignment. Chemical shift at 6.81, doublet of doublet, with J value 16.09 and 7.4, that belong 1 proton. This means that we have CH in here, adjacent to 2 hydrogens. One will be trans with high J value 16, and another one flexible, average of 7.4. Peak at 7.53 doublet, 16.09 hertz, 1 proton. This means that we have here the proton adjacent to only 1 proton in trans position. Peak at 7.73, that's doublet, J value 9, 2 protons, and 8.29, again another doublet, J value 9, 2 protons. This indicates that we have here AA prime XX prime disubstituted benzene, 9.78 doublet, value of J value is 7.4, 1 proton. This means that we have aldehydic proton adjacent to an H. And this peak belongs to the CHCl3 traces of undeturated chloroform. Here we have to start with distinguishable peak. This peak 9.78 belongs to the aldehydic proton adjacent to 1H, J value 7.4. This is free rotation. That's why we see this J value. Here we have doublet and doublet, 2 sets of doublet at 7.73 and 8.29, as we mentioned, belong to the AA prime XX prime disubstituted benzene system. For the peak at 7.53, doublet with J value 16, which means that we have proton in trans with another proton coupled J value 16, and peak at 6.81, that's doublet of doublets, J values 16.09 and 7.42 belong to this proton. Well, this is coupled to the aldehydic as well as to the olefinic proton trans. We have unsaturation. We have one in here for double bond, and double bond here, another one is two, and we have here four benzene ring that makes 6. So far from here we have 6. Let us see if we have one more. Let's go assign. We have C9H7NO3. We found out fragment of C3H3O and another fragment C6H4 that leaves the residue of NO2 fragment. Put them together will give us E3,4 nitrophenyl This compound has one double bond O, that's one unsaturation, double bond here 2, and as we mentioned here we have 4 unsaturation that makes 6, and one more double bond in here makes 7 of unsaturation. So let us check the chemical shift, do the calculation, and make a table to compare. Yes, this is matching well, this is matching well, this is matching well. So all peaks are matching well, calculated and observed, and this is the structure. E3,4 nitrophenyl acrylaldehyd. See you next session.